Hi, good morning. I'm Genta Suzuki from Digital Latitude. And today I'm going to talk about technology to link paper maps and mobile phones. First, I'll show you the demonstration video of the system. This map is a paper map, and this is a Kamakura city map in Japan, and this is a mobile phone sold in Japan. And this technology realizes identification of location information that is latitude and longitude information in paper maps using camera phones. And I'll show you the videos. When users start applications and the camera phone reads latitude and longitude information from paper maps. And this is a color preview image. And we move the camera phones, latitude and longitude tracking them. And then when we use a button, this application shows the digital maps on Google Maps. And this demonstration, and this map is a Japan map, and there are the same drawing pattern that is C, but our technology can distinguish the C, and this is a latitude and longitude of the sea, reading by camera phone, and this is a latitude and longitude of other area of the sea. And this is a demonstration video. And the reason why we developed this technology is to combine the advantage of digital maps and paper maps in the mobile situations. Digital maps such as a Google Map provides dynamic content and up-to-date information. On the other hand, paper maps have static content, but they have bigger and higher resolution, so they are easy to read, and they also have zero power consumption. And in order to combine these advantages, augmented paper map system have been proposed. And in augmented paper map system, mobile device recognizes location in paper maps and shows dynamic contents of other operations. And this is a related work, and this system displays a Wikipedia content by reading a paper map using camera phones. And the Ken will develop a system to set a destination of navigation system by pointing at a that device. And when developing the augmented paper maps, a major challenge is how to recognize a paper map correctly and reliably. And there are some related work. And the first work uses RFID to recognize a paper map. And PDA with an RFID reader reads a paper map in paper map that RFID tags are embedded. And the second related work uses Anoto technologies. In Anoto technologies, infrared absorbing dots are printed on the paper map, and a special digital pen called Anoto pen reads dots and recognizes the position that the pen is pointing to. And other related work uses image matching technologies. And this related work matches image patches surrounded by black dots, 4 black dots, with stored image data. And last related work matches patterns of the point of intersections with stored data. although there are a number of technologies, when it comes to improve these systems and promoting for their practical use, the recognition system must meet two requirements. The first requirement is about the hardware, and the system needs to be applicable to ordinary mobile phones and paper maps. This is because cost of the introduction will be smallest. And the second requirement is to do with the recognition software. The system needs to provide a scalable recognition. We think the scalable recognition means the system can accurately and promptly identify the map locations even if there are a huge number of maps with different designs, different scales, and they show different locations. So this table shows which related work meets which requirements. And RFID and another technology uses special hardware and special maps, but they can identify the unique IDs from the map. And image matching technology uses ordinary mobile phones and paper maps, but they cannot distinguish the same drawing patterns, which shows different locations. So we think no related work meets both requirements. Towards the requirements, our approach is to embed the latitude and longitude coordinates invisibly and print them on paper maps. And the camera phone recognizes the latitude and longitude coordinate directly. And that directory means recognition works as in a standalone fashion, and it doesn't match the camera images with stored data. And for invisible data embedding, we use a yellow shading pattern. And this method shows uses the fact that the yellow shading pattern is hardly recognized by the human eyes, but the camera phone can recognize it. And this is an image we use, and and this map has a natural appearance, but you can see the yellow shading pattern in this zoomed-in image. This is a yellow shading pattern. So the human eye can hardly see the yellow shading pattern, but camera is sensitive to it. And in addition, ordinary color printers can print the yellow shading patterns. And this embedding method is used our earlier work, FP code. And in FP code, invisible data embedding technology for color images, and this is aimed to alternate barcodes and two-dimensional codes. And in FP codes, 12-digit numerical data can be embedded into printed images with yellow shading patterns, the same method. And we start a commercial service of FP code in Japan, 2006. And the technology today I will show you is extended technology of FP code optimized for paper maps. Now, I'll show you how to embed the latitude and longitude data into paper maps. There are 4 steps for data embedding method. And the first method, map image, is divided into grid by latitude and longitude lines. And this map is drawn in north at the top. So the horizontal line, black line shows latitude lines, and vertical lines shows the longitude lines. And we call the grid surrounded by the latitude and longitude lines a map grid. And in the second step, data bit strings, including location information, are generated for each map grid. There are four data, and latitude and longitude of the top left corners, and latitude range from top to bottom, and longitude range from left to right. From this four data, we can know the all latitude and longitude coordinate of all four corners. And these data are changing into binary coded form, and the generating and the data embedding system generating a BCH error collection code from this code and attached to the location code. And then in the third step, and these data bit strings are embedded by changing the blue levels. In RGB color models, blue channel complements the yellow channel. So we change the blue levels instead of changing the yellow colors. And